Hello, everyone. I'm Bradley, either way. Brad Hacker. I don't know. There's a lot of names that go around. I'm going to be presenting today on cloud security. So this is something I learned a lot about over the summer. This is only part one of my presentations because cloud security is a very large topic. So today we are going to be talking about basic cloud services, giving you context. I'll probably be presenting next week or the following week on part two, where we will learn about securing these services. But first, we need a little bit of context. So there are a lot of competing cloud providers out there. Some of the big ones, AWS, Azure, GCP. There's tons of different cloud providers out there, but what you really need to know is that they're all extremely similar. So in this diagram here, you can see that there's a lot of there's a comparison between all the different products of each of these cloud providers. So you have like VMs and networking, platform as a service. There's a lot of buzzwords up on the screen. Hopefully by the end of this presentation, you'll have like a pretty good understanding of what this diagram means. Just know that when you are moving between cloud environments, as long as you understand one of them, you kind of have a basic understanding of all of them. This presentation is going to be focusing on AWS because that's what I work with mostly. So that's where we're going to go. Thank you. So here's a broad overview of a lot of the services that I'm going to go over. We're going to go over some stuff like enterprise management, which is not something that a lot of people get to mess with. This is like at a high level, managing from an enterprise environment. How do we manage like the broad overarching policy, as well as down to like the low levels. So our VMs, our Lambda serverless functions, databases, buckets, storage, etc., down to the very raw technical details. I'm going to try and keep this extremely high level for you guys so we can just focus on giving context to the second part of the presentation. So first, we're going to go over some terminology that I may or may not use during this presentation. I just want to get you oriented in the cloud space. You're going to hear these buzzwords run around, and you're going to see these acronyms kind of everywhere right now. Cloud is very big. So you see these like AAS like acronyms, and there's a bunch of them. There's a bunch of them that have like different letters in front. Here are some of the common ones. So we have software as a service. Really what this is running the application without you having to like manage the underlying system. So think like Shopify or Squarespace. So those are just some of the ones I can think of off the top of my head. So these, you don't really have to manage anything except like the content on your application, right? We also have something called platform as a service. This is a little bit lower level. So you actually manage the software piece of it without managing the actual like underlying operating system that it's running on. It's probably running in a container or something like that. So you don't have to go in, SSH in, manage the VM itself. You can actually just manage the software. So think like WordPress.com. You have full control over the WordPress itself. You can update WordPress, do whatever, but you don't have to manage the actual VM that it runs on. Then we have infrastructure as a service, and this is you actually managing the VMs that you're running on, the networking, the actual VM itself, except you don't have to manage the actual physical server that is running on. So I don't have to have a physical server. I can just tell AWS to spin up a VM for me. That is infrastructure as a service. There's also this term called serverless. I've already said it in this presentation. So this is when we run code on a shared infrastructure with everyone. There are like security guidelines around not allowing people to talk to each other, but essentially you share infrastructure to run code on without having to spin up an entire virtual machine for your small little Python script, right? If we need very little resources, we can run it in a serverless environment and only get charged for our brief code runtime instead of having to buy a full VM. It's a lot cheaper to run code this way. So we're going to talk about some organizational services within AWS. So the AWS organizational structure is very much like a tree. If you know anything about Microsoft Active Directory, it operates in sort of a similar way. Every organization has a root, This is the root of the tree. Every organization will have a management account. This is like, I don't know, the golden ticket, right? If you can get access to this management account, you basically have access to literally everything. So these are like the most secure accounts. Within your organization, you can have multiple accounts. And think of these as like departments within an organization. It's mostly used for like billing purposes to separate who to charge what. But you can apply different policies to different accounts, and accounts can hold resources. These can also be placed within organizational units, etc. And this is basically what I just said. The organization is a high-level like container. The OUs group kind of other objects, other OUs or accounts, and accounts can hold resources. Oh yeah, and then any policies that we'll talk about later will kind of trickle down this tree structure. So let's talk about basic access control. Does anybody know what access control? Can everyone give me a brief definition? Anthony, what you got? All right, yeah, principle of least privilege is what Anthony said. So really what access control focuses on is what should and should not, or what I should and should not do, right? If I am a student at RIT, I should not be able to go modify my grades. But if I'm a professor, I should be able to go modify a student's grades. Sound about right? All right, so really, so AWS has something called service control policies, and this is applied to accounts, and I believe also, well, yeah, it's applied to accounts. And so we can talk about the IT department's account, and we can allow and deny them permissions to different AWS services. So the IT department can spin up VMs, so they can use the EC2 service, but they cannot use something like CloudTrail, which we'll talk about later, because the IR department uses that. SCPs evaluate all policies equally, so if you have multiple policies applied to an account, a deny in any single one of those will override all of the other ones. There is no like order of importance, they're all applied equally. And then if you never explicitly allow the permission, there is an implicit deny, so you have to explicitly allow permissions on your accounts. This is like an example of some syntax. So you can see here that this is how we restrict the regions that you can deploy certain resources into. This is good for like, let's say, your company has, dealings where you're not allowed to touch a specific country with your resources. This is great for that. You can restrict which regions you can deploy your resources into, so you never have to run into that. Like I said, SCPs can be inherited. Here's a quick example of how the inheritance works. It's a little bit of a complicated diagram, but this is the best one I can find. So running through a quick example, we have a user, John Doe. He's in the RITSEC user's account, or OU, and he wants to create an EC2 instance. So we have a policy that's applied to the RITSEC user's organizational unit, and then we have our implicit deny. So if we take a look, okay, I forgot to change that title. That's my fault. So as you can see here, we never explicitly allow the run instances permission within the user's security policy. So we do a pass action, and it will immediately move to the deny and deny John Doe the action to create an EC2 instance. So next, there's something called Control Tower. Control Tower is kind of how it does a few different things. One of the main ones is making accounts. It automatically provisions accounts for me. So if you need to create a new student within RIT organization, you can kind of create a template for a student, and it will automatically create accounts for you. You can also define what are called guardrails. This is like high-level governance of accounts and resources. So think, we never want to allow our S3 buckets to be publicly accessible at any time within RIT. Guardrails will notify you if someone does something against those policies. And then it provides a nice dashboard, so you view your overall security posture, notice if you're going past any guardrails, etc. So let's talk about authentication and permissioning. So there's this big thing that you might see a lot when you talk about AWS. This is IAM. It stands for Identity and Access Management. So there's a few different little like pieces of vocab that are associated with IAM. So first, we have an account. This is really kind of an organizational unit. It represents mostly like a billable group within an organization. Resources get billed to an account, and then you can do stuff from there. So for example, if the organization was RIT, we would have accounts for ITS, the CSEC department, the CS department, etc. We can have IAM users, and these represent a person or application within an account. So for example, myself. And then we also always have a root user account. This is like the default user within an account that gives you kind of every permission. This is like the, we forgot the password to the admin account. Now we need to go like fix things. Usually you never use this. The users can be put into groups, usually used for like permissioning. It's another form of like OUs within accounts. Roles are super important. This is something that a user can assume. We'll talk about that. Think sudo. When you think Linux, when you have to do an action that requires root permissions, you use sudo. You never log in as root. You always log in as a non-root user, and then you use sudo to do an action. Think, like Anthony said, principle of least privilege. We have a principal. Whenever we talk about an IAM principal, that's someone who's authenticated or authenticated as a role to perform actions. That's like their effective permissions. And then IAM identity, that's just a user group or role. So IAM policies I alluded to earlier, these can be applied to any identity, so user group or role. And they're similar to service control policies. They allow and deny actions, but they only affect the attached identity. They don't like trickle down like the SCPs do. So this is kind of the authentication flow that someone should be following. So I would authenticate as whatever my identity is. So whether it be a user, a third-party application, or maybe I do a single sign-on with AWS. Now I'm authenticated as a user. But if I want to do anything, I should never have any permissions when I'm logged into a basic account. What I should do instead is have permissions to assume a role. So whether I'm a DevOps engineer, whether I work in the billing business department and I need to log in as accounts payable to see how much we're spending on AWS. Or maybe I'm a web developer and I only need access to our web servers. Well, these roles should then have permissions to do what that action needs access to and nothing more, the principle of least privilege. So then we should perform actions as those roles and not as our users. There you go. There's a role workflow. So like I said, the roles are kind of, think of it as impersonating someone. You gain a higher level of privilege, think sudo. There is something within AWS called KMS, or the Key Management Service. So think SSH keys, right? That's a very common usage of our cryptographic keys. When you SSH into a box, if you don't want to use a password, you can use a key to identify yourself. This is asymmetric key encryption. You can learn about it, crypto, 140, etc. There's a few different classes that mention this. There's a few different types of keys. So there is AWS generated keys. These are like automatically generated by AWS. So for example, the keys for the root account will be automatically generated for you by AWS. You have to download those at time of creation. Otherwise, they're lost forever. There are customer generated keys. So you can like click generate a key for me in AWS. That means that you requested an additional key. And then there's also customer provided. So if you have an existing key that you want to upload, you can upload that to AWS. So here's an example. This is like very complicated right now. We haven't learned about a lot of the services that are going on here. But this is a good example to look back on after the fact, after you understand what's going on, and see how the data encryption at rest works with S3 using the Key Management Service. So let's talk about computing, right? We want to run VMs. We want to do something like that. So you're going to run into your basic AWS service, Elastic Cloud Compute. That's what EC2 stands for. I didn't actually know that before I really did research. So high-level overview. These are virtual machines. You can customize them based on CPU, GPU, and RAM requirements. Yes, you can attach GPUs to your EC2 instances. They are deployed from base images, so you can have both public and private images. The public ones you get from the AWS Marketplace. Private ones can be uploaded within your organization. But these things can be used for like basic servers, firewalls, any third-party software that you need to stand up within the cloud. So here's an example of what one looks like in the AWS console. There's a little bit of a dated screenshot, but as you can see, there's a whole lot of metadata associated with it, but we don't really see a console. That's because you need to go SSH into it or something like that. So EC2's instances can have permissions. Roles can also be assigned to instances. So let's say your web server needs access to your database. You can give it a role so that it can now access your DynamoDB instance or something like that. We'll talk about DynamoDB later again. Oh yeah, and then yeah, like I said, they have permission. They then gain permissions to interact with other AWS services, so that way you can talk directly to them. And this kind of helps things be secure. Let's say your EC2 instance is breached. You don't want it to instantly have access to everything else in your AWS environment. So you have to set explicit permissions to allow it to talk to other things. So EC2 Security Groups. This is something that will be common. You'll hear thrown around when we talk about our infrastructure and OpenStack. Security groups are super simple. They're essentially firewall rules at a network interface level. So your EC2 instance has a network interface. It'll plug in an Ethernet cable to a PC. Think that. Each of these interfaces have security groups applied. They're basically firewall rules. They list like allow and deny. You can specify ports, protocols, source destination IPs, IP ranges, etc. There's a lot of configuration, but you specify exactly what traffic can and cannot flow through this network interface. This is super important because by default, no traffic is allowed through a network interface for security reasons. You have to explicitly define what you want to allow. So for example, this EC2 security group is going to allow SSH, as you can see by the port range, and there's some predefined ones, but you can do SSH from anywhere. You can specify where the source IP is coming from. So let's say we want to only allow RIT students to SSH into this EC2. Well, we have a public IP range here at RIT, so you could allow the entire 129.22/16 net. Similarly for web traffic, typically if it's a web server, you want anyone to be able to go to the web server, so you would allow it from anywhere. If we didn't have that, you wouldn't be able to access the web server. Traffic would just get eaten. So there's another thing called elastic block storage. So think of this as like an external hard drive for your virtual machine. You can create what are called volumes. Volumes kind of are similar to like a physical drive. Volumes can then be mounted to instances. This is where all of your storage happens outside of your operating system. When you attach an EC2, it has a very small amount of storage for its operating system, and then an EBS volume gets mounted to it for the rest of the storage. You can take snapshots of your volumes to make sure, oh, we're going to update this application. Let's snapshot just in case the update breaks things. We can roll back the snapshots or the volume to a previous snapshot. Think of snapshotting your VMs, right? This is just for storage, though. Amazon also offers a relational database service, or RDS. So this is just a SQL database. It's kind of a special type of EC2 instance. In the back end, it really is just an EC2 instance. But you can just easily say, I want a MariaDB, Postgres, or Microsoft SQL, a bunch of different providers. They have them listed. You just say, I want one of these SQL database instances. And then you specify a connection to an EC2 instance. Like I said earlier, it'll automatically create some permissions between those instances, allowing them to talk to each other. But if you do not explicitly create that connection, you will not be able to talk to this SQL instance from your VM. So those are super important. Basically, if there's anything we picked up so far, it's that within AWS, if you do not explicitly allow it, it will not happen. So you need to go through and make sure you're configuring everything for every possible action that you want to do. So let's talk about networking. Networking in the cloud is a little bit complicated. So we are going to talk about something called virtual private clouds, or VPCs. This is a term that kind of gets thrown around. And especially me, I kind of knew what it meant, but I didn't really. But really, it's pretty simple. It's just an isolated network. It can contain multiple subnets. So let's think of a VPC as just your own network switch. The subnets you create within it have to kind of be defined so AWS knows which traffic to drop and which traffic to allow. But you can define multiple subnets within it, so you can have multiple LANs. By default, VPCs cannot talk to each other. They have to explicitly be connected. So like I said, think of your isolated switch. If you didn't have anything connected to that, to the outside world or to another switch, you could not talk to anything outside of your VPC without explicitly connecting it somewhere else. So here's a great example. We have a VPC with a router and an internet gateway. We'll talk about those in just a second. But for now, just focus on the VPC. It's a very isolated internet or local net outside of the internet. You could do what's called VPC peering, and this is how we connect multiple VPCs together. So let's say I have two LANs that I want to talk to each other. I would do VPC peering. They can be in the same or different accounts. This is kind of complicated, right? Like, let's say we have the IT department probably needs to talk to, or like ITS would probably need to be able to talk to the CSEC department's accounts, probably. So they can be in same or different accounts. We would do peering between those two. Both ends have to approve it. You can't just like peer to random VPCs because that would be a huge security risk. But it has to be approved. And then you have to configure manual routing rules for those VPCs. So what I mean by that is if you're connecting from one subnet to a completely different subnet, you would need to explicitly set routing rules saying that this subnet exists over here, go talk to that VPC in order to find that subnet. It doesn't automatically know where all the subnets are. EC2s receive IP addresses in different ways. So if you deploy your EC2 in the default VPC, you don't create one, you just deploy it in the default AWS VPCs, they will get a public IPv4 address by default. This means that your EC2 instances are now exposed to the internet by default. So if it's an internal instance, you probably want to create your own VPC first to make sure that you're not accidentally exposing this. They can also have private IPv4 addresses, which they will get in the default VPC as well, within your VPC. If you create your own VPC and you have your own little private network, you get your private IP address, you will need to use something called an elastic IP to get a constant public IP. By default, the public IPs that are assigned to EC2s are released whenever you stop an instance. So like shut it down, hibernate it, or if you delete it. Your IP address is instantly released back to the big AWS pool. So if you want a constant public IP for something like a web server, you need to use an elastic IP. Of course, everything that you need to use costs additional money. So just keep that in mind. So transit gateways are essentially routers between these VPCs. That was the router that you saw in the previous diagram. They can attach to VPCs. You can connect instances directly to them. You can also have VPN connections that go in via a router. But you have to be very careful about these because you can accidentally connect two things that you really don't want connected. For example, connecting your development and your production environments. If your development environment has a vulnerability, you do not want someone to be able to pivot into your production environment via transit gateway. So you have to be very thoughtful about what networks you're connecting with a transit gateway. So here you go. Here you see a transit gateway. It's connected directly to one of the EC2 instances. We have an AWS Direct Connect, which I will talk about later. It can be connected to another transit gateway via peering. You'll hear the peering term a lot. We have a VPN connection in, two VPCs connected. So you can see it can be connected to a lot of different things. Next, we have internet gateways. It's kind of like a special version of a transit gateway. This is what connects VPCs to the internet. You're probably going to want internet traffic on your VM. Like, my best bet is you're probably going to need internet. So if your resources, I misspelled that, sorry. If your resources need to be publicly accessible or a resource needs internet access, you would do something like this. Most of the time, you're probably going to use something called a NAT gateway instead. They are different than internet gateways because NAT gateways don't allow inbound traffic. So if you do not need a resource to be publicly accessible, i.e. someone from the public getting access to your resource, you would probably use a NAT gateway. That way you can still get internet, but no one can kind of get in. You would only have explicit access. Yep. So here's an internet gateway example. All traffic goes through the internet gateway before it goes out to the internet. And it's connected to the VPC right there. So let's talk about on-prem connectivity. This is something. Oh, it froze. 1 second. Sorry, we're having technical difficulties. Uh-oh. Where did the Zoom go? Oh, it's reconnecting. Sorry for the technical difficulties. I was kind of on a roll there. Thank you, Alex. All right, let me just rejoin here. All right, while I'm at it, 1 second, folks. Alrighty, we're back. We just had a brief internet dropout. Stream is still going, right? All right, we're good. Okay, sorry. Getting back into it. This diagram, example of how we would use an internet gateway to get traffic from a VPC to the internet. Yeah. Oops, that is not the next button. So let's talk about on-prem connectivity. And what I mean by on-prem is when I'm talking about a corporate office. So, you know, my best bet is that your enterprise is going to have some form of physical office, whether it be for all employees or just some. You're probably going to want to be able to get connections from that office directly to AWS, especially if you do things like cloud host your Active Directory or other things like that. You're going to want to be able to talk directly from your local network to the AWS network. It's a very common use case. So you have two kind of different options. One, I'm going to talk about first, actually the bottom one. It's a very common thing that we do, especially in enterprises, is having a site-to-site VPN. Okay, this means that your network will have an encrypted tunnel over the internet that then terminates at AWS's data center. The kind of downfall to this is that you are now sharing your standard internet uplink. Let's say your corporate office has a 10 gigabit uplink to your internet service provider. Well, you only have 10 gigabit of bandwidth to share with both your AWS traffic and your standard office network traffic out to the internet. So you're kind of sharing that bandwidth there. AWS actually, and this is very surprising to me, offers a direct connection possibility. If you are close enough, and I don't know what the definition exactly for close enough is, but if you are close enough to an AWS data center, you can physically attach a separate uplink from your office directly to the AWS data center. So you will have two outbound connections from your office. You will have one to your internet service provider. You'll have another one to AWS's local internet service provider that direct to the data center. So you will have dedicated bandwidth going straight to AWS, and you do not have to clog up your standard internet uplink. This is private, but this uplink is not encrypted. So keep that in mind. VPNs offer encryption over the internet, but if you want to stay off the internet, have a local connection to your AWS environment, it is not encrypted. All right, so remember at the very beginning, we're going to shift from networking now back to a little bit of computing. Remember at the very beginning when I talked about serverless, this is when we have code, we want to execute it without having to spin up a full VM to run our code. A common example that people don't think about is S3 buckets, or the simple storage service. This is actually a serverless component of AWS. You do not spin up a VM to host your files. This is just a native service offered by AWS. It is what we call object-based storage. So you upload a file that is an object. These S3 buckets can be secured by SCPs as well as individual resource policies. Those are very similar to the SCPs, but we talk about restricting specific S3 permissions, such as like upload file, download file, list file, etc. You can restore and retrieve application data, files, logs. This is basically for you to shove any data towards, it'll store it. It's very, very flexible. So for example, I have this GIF, I think it's working, of someone, not myself, unfortunately, uploading a file to an S3 bucket. They're really hunting for it. All right. Interestingly enough, I do believe, and someone can correct me if I'm wrong, but when you upload things like CSV files to your S3 bucket, you can actually define within your logging rules, which we will talk about later, you can actually define logging rules to go browse those CSV files. And then let's say, for example, you want to upload a CSV of credit card numbers or passwords or social security numbers. It can actually identify that you accidentally uploaded a social security number to your S3 bucket and say, hey, we shouldn't have this sensitive data unencrypted in an S3 bucket, and it will notify you. Not necessarily you, whoever's in charge of that. All right, so now that you got to view that beautiful GIF, we're going to talk about AWS Lambda. And this may or may not be a word that you've heard thrown around before when we talk about AWS. It's pretty big within the AWS community. This is how we do serverless computing. So like I said before, this is the exact way you do running code on a shared environment. You can use events to trigger your code to run at any given time. You can run code in common environments. So I think these are the three that it supports. It may support more in the future when it comes to AWS, but you can run Node.js code, Python, or actually Java. So you can trigger this natively from AWS services, such as like upload a file to S3, then we run a Lambda function. We talk about API gateways in the future, run a Lambda function as soon as we get a web request. You can also use, I think, things like webhooks and stuff like that to integrate with other software as a service solutions. This is an example of a Lambda function. It's just a little bit of Python code that runs. It's a function, and then it returns some data. You can see the execution result at the bottom. This can interact with other AWS services such as DynamoDB to store data. So the AWS API Gateway, which I talked about a little bit earlier, this is how we do an API, and what I mean by that is a web server that will take in requests and return some data. Typically, you hear the term REST thrown around when you talk APIs. But this is how we do it without a full web server. We don't have to spin up a VM anymore for our APIs. We can create serverless API endpoints. I can define a GET request to /API/people will return this by running a Lambda function. and I can save a lot of money by doing it this way. We do not have to have a VM running 24/7. We only have to have code that executes whenever a user requests it. So it's on-demand computing. So this can be interfaced for web apps. You can actually kind of proxy requests through an API gateway. Uh-oh. Our stream is disconnected. Sorry, we're having so many technical difficulties today. Yeah. Un momento. Yeah, the internet cut out. It's trying to reconnect. All right. Okay. I don't know if the stream's going to come back right now, but I believe we are still recording, and I think we can still get Zoom to work. Oh, okay. We're back. We're back on the stream. Perfect. Sorry about that, folks. All right. So as I was saying, we can actually proxy our web application via an API gateway. So if we have, let's say, a few different APIs, and we want to just expose them via one API endpoint to connect to multiple different backends, we can kind of proxy that traffic. Or we can, let's say, like I said before, if we want to like get a list of people from our database, we can just run Lambda code to go pull that data instead of hosting a full VM for a small little endpoint. You can create multiple different endpoints. So API create user, this is how we like create a user in our DynamoDB database or something like that. There's two different solutions, a RESTful API and a WebSocket API. RESTful APIs provide that typical create, read, update, delete operations, as well as WebSockets offer real-time communication with an API. So you can have real-time messaging back and forth between, for example, a browser and a server. So this is how a lot of like common chat applications work. You will be sent all the data in real time. It'll be pushed down from the server to the client. This is an example API gateway. You can see on the very left-hand side, we have get and post requests for the products endpoint, as well as we have a product / and then a product ID. We have get, put, delete. These are our typical create, read, update, delete operations. You can go check out Alex's web presentation for a little bit more information on how those kind of web requests work. So it's kind of out of the scope here. But this is what the backend method execution looks like. So you can see this one is actually proxying data for some other API. So you can see that we send a GET request to the root of this API. We can handle authentication. This is how you can add authentication to your APIs without handling it natively within your API. You let AWS handle the authentication. Then it will proxy the request, passing through all the inputs, as we see here, to this stockmarket.streamdata.io website. And this is how we can create an API that interfaces with another API. And then it repeats the output back to the user. So DynamoDB is something I mentioned a few times. This is a serverless NoSQL database. What I mean by that is instead of storing documents and like kind of rows in a table, it stores data as a key value pair. It does support some like JSON stuff. It requires a little bit of additional configuration, but this has built-in backups. You can replicate this data across regions very easily to kind of create a CDN of sorts. You can also integrate this with your Lambda functions. Like I said, you don't have to stand up an individual database for your individual web server. You can just have everything run in the serverless environment. You can hook this directly to API gateways as well, and a lot more services. This is an example of a project or Happy Marketer table. Happy Marketer database. We have an items table, and these are all the items, the key value in that document. As you can see here, there's the standard key value pair, and then down here is some more expansion of that JSON syntax I was alluding to. All right, so we've been able to do a lot of actions in AWS, but what's super important is tracking who's doing what. When you're in an enterprise environment, if someone's account gets compromised, you want to know exactly what they did, when they did it, etc. So logging is super important in order to be able to track down who did what and when. So CloudTrail is one of the main services that AWS offers. It's used to audit, and what I mean by audit is like kind of collect a list of actions performed by users, roles, and AWS services. So if your EC2 instance starts automatically talking to your SQL database and you're like, how did it do that? Well, you can go check it out. You can start with the exact action of it communicating with your SQL database, and then you can work your way backwards from there. Figure out how it got those permissions. This can help identify security instances or incidents, as well as you can export all of this data straight to an S3 bucket for SIM integration. SIMs are very often pull from an S3 bucket for data. That's what I was alluding to earlier with the S3. You can dump logs straight into there. CloudWatch is an easy way to watch your CloudTrail data. So it collects data from CloudTrail. You can visualize this for monitoring purposes and dashboards. You can even have it auto-respond to events. Let's say someone creates a new administrator user, and you know you never want to create new administrator users. You can have it automatically delete that administrator user account. So that way we can have quick automated responses to incidents. You can also analyze incidents, like I said, your EC2 instance talking to something it shouldn't be, and it will help you identify automatically the root cause of that incident. You can also do VPC flow logs. So this is monitoring all the inbound and outbound network traffic from your virtual private cloud and from each interface connected to it. You can export this data to CloudWatch directly to S3 for like an external app to analyze. There's a lot of things you can do, but this is like network traffic monitoring, basically. Think Wireshark, but distributed in your cloud environment. All right, so I know that was a lot of information. That's really a primer on the real security piece, which is part 2 of this presentation. Does anybody have any questions? I know I ran through like a lot of stuff. Yeah, what's up, Alec? Perfect. So Alec asked, where did I find all of this information? So I will say the AWS documentation is actually extremely good. It's very dense and spread out. There's a lot of different pages you have to click through to find all this information, but you can do that very easily. Some of this information I learned while on co-op, but I went straight back to the AWS documentation to learn a lot about this. AWS offers a certification called AWS Certified Cloud Practitioner. Great cert to get, especially if you're going to be working with AWS services. It teaches you basically everything that I talked about a little bit more in depth. So you learn about all the AWS services, how to use them, etc. It's only $100 to take the exam. I think it's like 65 questions, multiple choice. What's up, Alex? So personally, I actually haven't worked a ton with GCP. Well, I haven't worked at all actually with Azure. I've worked a little bit with GCP, but going back to this diagram at the beginning, now that I've talked about all these things, you can see a lot of the stuff that we talked about, where we have instances, EC2 specifically. We didn't talk about ECS, we talked about Lambda. So you can see Azure functions are equivalent to Lambda, and they call it cloud functions in GCP. We talked about S3. Azure has block blob storage, and Cloud Platform calls it cloud storage. There's a lot of these different services, but you can go look in the documentation. But it is very similar. The cloud requirements for any customer of these people is very common. Like no one's going to require a very like niche use case that one would offer over the other. They're all very similar. Competition in the cloud space is kind of I don't want to say plateaued, but pretty much every cloud provider you're going to have offers very similar stuff. What's up, Malik? Yeah, so Malik was asking about specifically how VPCs are internal and internet gateways, like kind of the use case there. So yes, VPCs act as an internal network. By default, the internal networks have no outside communications. Internet gateways are used to connect those virtual private clouds. Private being the key word, it's disconnected. Internet gateways, anything with gateway in the name is going to be connected to something else. So our internet gateway is connected to the internet. Specifically, most of the time, you'll probably use a NAT gateway. That way, all of your traffic uses network address translation. That way, we can kind of hide our traffic. Security through obscurity. I know everyone loves that term around here. Any more questions? All right, I'm hearing none. So definitely, you're going to have to come back for Cloud Security Part 2. We're going to talk about everything that we talked about today. We're going to talk about how to make sure that that stuff is secure. So when you are doing it, potentially, if you're doing pen testing, you can go ahead and take a look at all these services and know when something is definitely not secure. All right, thank you guys.